Hey guys, hi. This is Aili Bhattacharya, your study buddy, and today is a very special day. So happy Valentine's Day to all my study buddies, all my Babu Shonas, and yes, to all my special monas who do not have Valentine. So here you have me, and we are going to study together. Okay, so yes, we are going to study today distributions as you can see in the first cover. Okay, now we'll focus on two things today. That is Bernoulli distribution and binomial distribution. In Bernoulli, we will understand what a Bernoulli trial is. And for binomial, we are going to do only one thing today, the mean of binomial distribution. I know, that's the trickiest part. It looks scary, but I promise you, we will go step by step, logically, clearly, no skipping and no confusion, okay? There will be just pure understanding, and yes, we can do it. So let us begin with the first slide. Look at here. What is first written? Parameter. Before we jump into distributions, we first need to understand this one word, that is parameter. What is a parameter? Parameter is a quantity or anything which takes a particular value. Okay. See, it can take a particular value in this distribution, and this describes a distribution. It is fixed, but it will be unknown. Okay, it is usually unknown. We don't know it yet. That's the whole mystery in this case. Okay, so in statistics, a parameter is exactly that, a fixed but usually unknown value that describes a distribution. Okay, take Bernoulli and binomial distribution, their parameter is p. Here, what is p? Look at here. See this P. What is P here? P is the probability of success, and we also have a friend of P. We call him Q. That is 1 minus P. Q is equals to 1 minus P. Then what is Q? Q is the probability of failure. Both P and Q are unknown, but they are fixed numbers. They don't change. We don't know them yet, right? That is the parameter. Now we will come to discrete probability distribution. What is discrete probability distribution? Discrete means the random variable takes the countable values 0, 1, 2, 3, like that. Now here you come with fx. What is fx? Fx is a PMF. What was PMF? We discussed it earlier. PMF is probability mass function. For Bernoulli, fx is equals to p of capital X equals to small x is equals to p to the power x into 1 minus p to the power 1 minus x, where x is equals to 0 and 1 and 0 otherwise. Okay. Now what is x here? X is our random variable. P of capital X equals to small x means the probability that capital X takes a value small x. Okay. What was the capital X? It is a random variable. And what is the small x? Small x is the value of that random variable. Is it clear? Now see, here capital X can take only two values, 1 and 0. What is 1? 1 is a success and 0 is failure. Now let's test it. If you plug in the values, look at here. If you plug in the values, if x is equals to 1, what do we get? P to the power 1, 1 minus p to the power 1 minus 1, which is 0. So 1 minus p to the power 0 is 1. So p to the power 1 is p. So it becomes p. So if the value is 1, then it means success. And what was p? P is the probability of success, right? Now let's test with 0. If x is equals to 0, then what happens? P to the power 0 into 1 minus p to the power 1 minus 0, which means 1 into 1 minus p to the power 0, which is 1. Then we get what? 1 minus p to the power 1, which is 1 minus p, which is equals to q. And what was q? Q is the probability of failure, right? See, this works perfectly. Beautiful, right? Now we will come to Bernoulli trial in the next page. Look at this. Wait a minute. Yes. See this Bernoulli trial. What is Bernoulli trial? A random experiment with two outcomes, success and failure, occurring with probabilities 1 and 1, p and 1 minus p, is called Bernoulli trial. Okay? What does this mean? This means three things. First, only two outcomes. Okay? Next is probabilities are constant. Third is, most importantly, it is one single experiment. One single experiment. So Bernoulli trial is equals to one experiment. So Bernoulli distribution describes one trial. Okay, just one. Now see, how beautifully I will extend Bernoulli distribution with binomial distribution, with Bernoulli trial to binomial distribution. See, what if we take Bernoulli trial and repeat it n times? What does it become? This becomes binomial distribution. Okay, see the definition here. Look at the definition. A random variable x is said to follow a binomial distribution with parameters n and p if it assumes only non-negative values and its PMF is given here. See, what does it mean here? There are two parameters here, n and p. What is n? N is the number of trials. And what is p? P is the probability of success in each trial. Okay? And then the PMF is given here. See the PMF? Fx is equals to p of capital X equals to small x is equals to n chooses x, p to the power x, q to the power n minus x, where x is equals to 0, 1, and goes on till n, and q is what? 1 minus p, and 0 otherwise. So basically, you have to understand that in Bernoulli, there is only one parameter. That was what? P. And in binomial, we have got two parameters, n and p. So, as I have already discussed, what is n? N is number of trial, p is what? Probability of success in each trial. Clear? Good. Now see this. This is the notation of binomial distribution. Okay. This sign basically means tilde. Okay. What is tilde? It means follows. So x follows binomial n comma p. If someone asks you to write the distribution, you write what? X follows binomial n comma p. N is what? Number of trials. P is what? Probability of success. Do you get my point? I've told this many times because it should be clear, right? Now, coming to a very, very important thing. This is very important. We are discussing here why we do this combination. Why this combination? Why do we have that n chooses x in the formula? Okay, let me explain this with an example. Suppose n is equals to 10. For this example, we toss a coin 10 times. Okay, we want exactly two heads. Then how many tails? Eight tails, obviously, right? Then the PMF will be what? As we have discussed, 10 chooses 2, p to the power 2, q to the power 10 minus 2. This 10 minus 2 is what? 8. So here x is what? X is the number of successes, which is 2, and n minus x is the number of failures, which is 10 minus 2, which is equals to 8. But why the combination? Why 10 chooses 2? Okay, we can think it like this. See, if we have 10 places, and we need to put h in any two places. Could be any two places. It could be first and last, it could be the first and second, it could be ninth and 10th position, it could be anywhere, right? How many such arrangements? Exactly 10 chooses 2. Exactly 10 chooses 2, right? That is why we use the combination, because the successes can be arranged in different positions. In general, what do we write? NCX, right? X places for successes, the rest automatically becomes failures. Now the binomial formula makes sense, right? Yes. Now see, here we come to the scary part, right? This is the mean of binomial distribution. See, for random variables, we have already discussed what is the mean, that is the expectation, right? So we want here E of x, which is expectation of x. And what is the formula for expectation of x? That is E of x is equals to summation of x dot fx, x running from 0 to n. Here x is the value, right? And fx is the PMF, and x runs from 0 to n. Now, in the next step, you have to substitute the value of fx, which is the PMF of binomial distribution. And if you substitute it, see what do we get here? E of x is equals to summation of x dot n chooses x, p to the power x, q to the power n minus x running from 0 to n. Now, in the next step, you have to expand the combination. Look at here, expanding the combination, which is equals to summation of x dot n factorial divided by x factorial into n minus x factorial dot p to the power x dot q to the power n minus x. Now watch closely. This is the step where most students get lost. Okay, see that x factorial here. Why have I written x factorial as x into x minus 1 factorial? Can you guess it? Yes, we can write it like this. See, if we take an example, see the logic here I have written. If we write 5 factorial, what is 5 factorial? It is 5 into 4 into 3 into 2 into 1, right? Which can also be written as 5 into 4 factorial, right? And 4 is what? 5 minus 1. So yes, it works. So basically, we can write this one x factorial as x into x minus 1 factorial. And if we write it like this, we can cancel out the numerator x with the denominator x, right? X in numerator and x in denominator. So it is gone. So basically, in the next step, we get, look at here, is equals to summation n factorial divided by x minus 1 factorial into n minus x factorial dot p to the power x dot q to the power n minus x. But wait, yeah, look at the denominator x minus 1 factorial. If x is equals to 0, what does it become? 0 minus 1 factorial. So it is 1 minus 1 factorial, right? Which does not exist. So we cannot start from x equals to 0 here anymore. We must start from x equals to 1. Okay, so basically this step you have to correct it yourself. Okay, while writing it, please correct it that in this step you have to write x equals to 1. Okay, limit changed, problem solved. Now see, just like we have written x factorial as x into x minus 1 factorial, we can do the same for n factorial, right? So in the next step, we wrote summation of n into n minus 1 factorial divided by x minus 1 factorial into n minus x factorial dot p to the power x dot q to the power n minus x, and you have to write the limit of x equals to 1 to n. Okay, now see, in the next step we use a logic. We use the logic as we want to match the power of p, match the power of p with the denominator x minus 1. Now how can we do that? We have x number of p's, right? If we have x number of p's, we can take out one p. Then what does it we will be left with what? P to the power x minus 1. All right, and here n is also a constant. So if we take out another n, then what are we left with? N minus 1 factorial. All right, then see what will be the next step. N into p, we took the constants out. So n into p summation x running from 1 to n minus 1 factorial divided by x minus 1 factorial into n minus x factorial dot p to the power x minus 1 dot q to the power n minus x. Now in the next step, you have to rewrite this n minus x as n minus 1 minus x minus 1. If you compute this, we will get n minus x only. We just rewrote it. Okay, now why are we rewriting it? Because we want it to look like a binomial coefficient. Okay, we want to look at like binomial coefficient. Now, if you write it like this, what do we get in the next step? N into p summation n minus 1 factorial divided by x minus 1 factorial into n minus 1 minus x minus 1 whole factorial dot p to the power x minus 1 dot q to the power n minus 1 minus x minus 1. Okay, and what is this? This is the formula of combination, right? So n into p summation n minus 1 chooses x minus 1 dot p to the power x minus 1 dot q to the power n minus 1 minus x minus 1. Now look at this. This will come in the formula of binomial expansion, which we have already studied in our previous classes. Okay, see the binomial expansion a plus b to the power n is equals to summation ncr into a to the power r into b to the power n minus r. And if we open it up, what do we get? We get n chooses 0 into a to the power 0 into b to the power n plus nc1 into a to the power 1 into b to the power n minus 1 plus, and it goes on till ncn into a to the power n into b to the power 0. So basically, if you want to expand this also, look at here. If you want to expand this one, then how can we do it? See, x is running from 1. Okay, so n minus 1 chooses 1 minus 1, which is 0. So n minus 1 chooses 0 into p to the power 1 minus 1, so it will be 0. So p to the power 0 into q to the power n minus 1 minus 1 minus 1 is 0, so q to the power n minus 1. And if you open it up, we will get something like this, right? N into p into n minus 1 0, p to the power 0, q to the power n minus 1 plus n minus 1 chooses 1, p to the power 1, q to the power n minus 2, and it will go on till n minus 1 chooses n minus 1 into p to the power n minus 1 into q to the power 0. So this can be written as a formula of a plus b to the power n, right? So n into p plus q to the power n minus 1. Then can you understand what is p plus q? P plus q is nothing but 1, right? How? Because what is q? Q is 1 minus P. So P plus 1 minus P is what? 1. And you can also understand it like this, like P is the probability of success and Q is the probability of failure. So if we combine both of them, we get 1. So what do we get here? N into P into 1 to the power n minus 1 is 1. So N into P. And we get the mean of binomial distribution as N into P. Okay, there it is. The mean of binomial distribution is simply n times p. And all that algebra, all those factorials, all that summation, and it collapses into something so simple and so beautiful. That is the magic of mathematics. Okay, and see, let us do a simple recap of what we learned today. We covered Bernoulli trial, one experiment, two outcomes, okay? And then we studied Bernoulli distribution, we studied the PMF, and there is only one parameter, which is P. And then we studied binomial distribution, we understood the PMF and understood the parameters N and P. And then we also got the concept of why we use a combination, why the combination appears. We understood it like on the arrangements of successes, and then we got into the most trickiest part, which is the mean of binomial distribution. We derived it step by step with no skipping and no shortcuts, right? So if this video helped you understand that scary summation, if it made you feel like, oh, that is why it is NP, so then please like, share, and subscribe for more BSc Statistics explained simply. And yes, if I give you a little preview upon what is coming up in the next video, we will do the proof of variance properties. There were two properties, right? The first one was variance of a plus x is equals to variance of x, and the next is variance of ax is equals to a square variance of x. And we'll also study the rth order factorial moment for binomial. And next up in the following videos, we will do the questions on finding variance. Okay, I'll explain everything step by step, just like today. And yes, that is all for today's session. Thank you so much for studying with me. Take care, and I'll see you in the next one. Bye bye. And yes, do not forget to check the notes out. Okay, so yes, bye bye. See you soon.